Hello and welcome back to the course on artificial intelligence. I hope you're excited about today's tutorial because we are taking our very first step into the world of AI, and today we're talking about reinforcement learning. It's a very important tutorial because it will underpin everything else that's going to be happening in this course. So let's get started. Here we've got a little maze, and this maze is our representation of an environment, and that's what we're going to be dealing with in this course. We're going to be dealing with certain environments in which our artificial intelligence is going to be performing, it's going to be taking actions, it's going to be looking to beat these environments, it's going to be looking to win in these environments. And here we've got an agent. The agent is our artificial intelligence. That's the person, or that's the mind that's going to be navigating these environments and learning from the feedback that the environment is going to be giving it in order to perform certain actions. And so the way it works is the agent performs certain actions in this environment, and as a result, the state in which it is in will change. So it might be further or closer or more to the left, more to the right. It might have a certain other parameters that describe its state, and those parameters are going to change. So the state is going to change because of the action it takes, and it will also get rewards based on the action. So every time it takes an action, the state will change and it'll get reward. Now, bear in mind, sometimes it might happen that it won't change the state. The action won't change the state, or there won't be a reward for taking that action in that certain state it was in. But nevertheless, the agent is going to keep doing that. It's going to be taking actions, changing the state, getting rewards, changing action, taking actions, changing the state, and getting rewards. And by doing that process, it's going to be learning about the environment. It's going to be exploring the environment, understanding what actions lead to good rewards and favorable states, and what actions lead to bad rewards and unfavorable states. And this is a very simplistic representation of a very global problem. So if you think about it, environments actually don't have to be just mazes. It's not just about getting out of a maze or finding a treasure in a maze. An environment can be pretty much anything in life. So imagine you waking up in the morning and cooking an omelet. So in order to make that omelet, you need to go through certain steps. You need to get the salt, get the eggs, get the frying pan, switch the fire on, and so on. And it does sound like a routine, mundane thing, but it's become routine because you've done it so many times. But in reality, it's an environment where you're performing certain actions. You're putting the fire on, you're putting the frying pan on the fire, you're putting all the eggs into the frying pan, and you're putting some salt on the eggs, and you're turning them over, and so on. So as you can see, there are certain actions which you're taking in certain states, and those actions lead to certain other states and sometimes rewards. So for instance, when you put the fire on and you wait, you're taking the action of wait too long, and then you put the eggs into the frying pan, the reward is going to be very negative. It's all going to burn. On the other hand, if you do all the correct actions in the correct times, so it's also very important to understand that actions should be taken at the correct points in time. So for instance, putting the salt in the frying pan before you put the eggs in might not be the best idea. You might want to take that action of putting the salt into the frying pan after the eggs are in there, so in a different state. So it's important to remember that. And at the same time, so if you take all the correct actions in the correct order, in the correct states, your final reward could be that you get an omelet which you can eat. And so that's a very basic activity in your life, but if you think about it, it is actually an environment, and you are the agent going through this environment and performing tasks. You don't really need to learn anything because you already know it pretty well, but at the same time you could learn. Maybe you could learn how to make a better omelet, or especially if it's your first omelet that you're making, you're probably going to screw it up, but you will learn from that because you will understand what actions lead towards states and rewards. And anything else in life, for instance, even trading on the stock market and buying and selling and getting certain feedback from the market in the sense of return, positive or negative returns, that's also an environment. And that's you participating in that environment as an agent. Driving a car is also an environment where you can turn the steering wheel, you can accelerate, you can brake, and so on, and you're getting feedback from the environment. And one of those feedbacks is a policeman giving you a speeding fine if you're going above the acceptable or allowed speed limit on that highway. And therefore, from there, you learn that, okay, that's not something that should be done because it leads to a negative reward. So rewards don't have to be just at the very end of the process. They can be throughout the journey, throughout the process. So those are a couple of examples. And in terms of AI, the simplest way to think of reinforcement learning is like training a dog. When you train a dog, you to give it certain commands, and if it obeys those commands, then you give it a treat. You give it like a biscuit or something. If it doesn't obey those commands, you tell it that it's a bad dog, or you just don't give it a treat. And through that process, it learns what certain commands, or what it needs to do, what action it needs to take in certain states. And the states are the commands that you're giving it. And based on that, it will get certain rewards. Of course, in the world of AI, it's not that complex. You don't have to give the AI treats. You don't have to have like a bag of biscuits with you every time. You just give it a +1 or a -1. So it's a huge advantage that in the world of AI, we've created these AIs ourselves. So the rewards that we're giving them, if you think about it, this is really cool. If the rewards you're giving them, they don't actually exist. They're just a plus or a -1 or a 1 or a 0, something like that. So it's all non-existent, it's all imaginary stuff, but at the same time it leads to great results. We can create these amazing things, these amazing artificial intelligences by just providing rewards which don't really exist, the plus and -1. It doesn't cost us anything, but at the same time it leads to results. So very similar to real world and that example of dogs, but here the rewards are digital and just numbers. And with that in mind, we can talk about a little bit about robodogs. I love this example. So this is just a random picture. It's not necessarily that exact robodog, that is trained through reinforcement learning. Some robodogs, especially the older ones, you'd have an algorithm in there. And this is actually a good example of the difference between pre-programmed agents and reinforcement learning agents. So you could have a robodog which is pre-programmed to how to walk. It will say, so in the algorithm behind the dog, in the software, it'll say, okay, so in order to walk, you need to move your left front leg forward, then your back right leg forward, then your front right leg forward, then your back left leg forward, and repeat that action. And that's a definition of walking. It's a function inside this dog. And then it might have, how to sit, how to stand, and things like that. Whereas in a robot dog that is trained through reinforcement learning, what happens is you don't pre-program it. This is the key concept to everything here, that you don't have any algorithm inside that is hard-coded into the dog. Instead, you have what we'll be discussing in the future. You have this reinforcement learning algorithm, which is told that, okay, so the goal is to get from where you are now, not knowing anything, to the end of the room, for example. And here are the certain actions you can take. You can move your right foot, you can move your left foot, you can move your right back foot, your left back foot. So here are all the degrees of freedom that you can do. You can move them like this, you can move them like that. So like a list of actions you can take. And your rewards are every time you take a step forward, you get a +1. Every time you fall over, you get a -1. And that's all there is to it. And then they just leave the dog and let it figure it out on its own. So the dog tries to stand up, it falls, and it realizes that, okay, I shouldn't do that action that led to me falling, because every time I fall, I get a -1, which is not good for me. Then, so it does the other action that helped it stand up. And then it figures out, it just experiments, tries things randomly, and then figures out that it can make a step forward by moving its right front foot. And it gets a +1, and it realizes, oh, I should do more of that. Okay, cool. So it now learns that it should do more of this and less of that. And through this learning process, it very quickly understands how it can walk. And those dogs that figure it out on their own can actually sometimes walk better than dogs that are pre-programmed. Because when we pre-program things, we look at the real live dogs or we use our own imagination how to do it. Whereas a reinforcement learning dog can optimize things on its own, and because it's an AI, sometimes it can get even better results. And that's how they can train these same robot dogs to play soccer. You can't train a normal dog to play soccer because simply the whole approach is different, and it's not something that probably a normal dog has been trained to do or has ever done in its process of its evolution. Whereas reinforcement learning robot dogs can very easily understand how to play soccer as long as you tell them what the rewards are, what the goals are, what the possible actions they can take are. So that is how reinforcement learning works in general. That's a quick overview of reinforcement learning. I hope that got you very excited about what's going to come next, because it's a completely different world compared to pre-programmed solutions or hard-coded solutions where you have the if-else conditions. This is very different, and we're going to be talking more about that In the meantime, we've got some additional reading for you. So if you'd like to have some supporting materials, here's a great article which you can look into. It's called Simple Reinforcement Learning with TensorFlow. It's got 10 parts. The link is here, and you'll find the full clickable link in the course resources. It's by Arthur Giuliani. It's a 2016 article. And you can follow along this course and also get additional information from that article. But bear in mind that that article is with TensorFlow, whereas in this course we are using PyTorch. So a different implementations, but at the same time you might pick up a few things here and there that might supplement your learning that we're going to be doing in this course. So great article to follow, even if you're not considering following it for sure. Just in case, check out that first part and see if you like it, see if you would like to read it a bit more. And then we've got specific to this tutorial about reinforcement learning. There's a paper by Richard Sutton, which is called Reinforcement Learning 1 Introduction. It's a 1998 paper, so quite old, but it's, at the same time, you can learn a bit about reinforcement learning, some of the examples like that omelette example and other examples of where reinforcement learning can be applied, and just a general overview of reinforcement learning if you are looking for some additional reading. And on that note, we're going to wrap up this tutorial. Can't wait to see you next time. And until then, enjoy AI.